Uh, First of all, let me emphasize, coil guns are easy to build, and it's easy to build one that works. However, it's difficult. It takes some good engineering study and tune-up to make it work really well. Some places that would benefit from some examination and more experiments would be in the magnetic flux path around that. If there were ways to improve the coupling between the magnetic field and the projectile, then surely there would be great benefits here. Fortunately, these days there are lots of software tools available. One of them is a finite element method magnetics package, FEMM. It does magnetic simulation. It's free, and you can get that from www.femm.info. Recommended stuff. I
And
wonder in
and
coil
bury
guns.
that link. And bury that link is on our website as well. So don't feel like these links that you need to copy those down.
Correct. Yeah. Thank you. I don't usually read them. Anyone listening, please visit the website and pull down the notes. All of these slides have a great deal of information, including links attached in the notes section on every slide. I wonder, for improvements in coil guns, if there are other types of switching devices that would work better than what I've done so far. And some that come to mind, I've used SCRs, silicon controlled rectifiers. I have a picture of some hockey puck style SCRs here to the right. In addition, there's mechanical contacts, there's MOSFETs, metal oxide semiconductor, field effect transistors, which have the promise of very low on resistance in the high current path. With the possible drawback, they get expensive when you go to really high current of thousands of amps, as we'd like to have. For less expensive switching, there's IGBT, insulated gate bipolar transistors. These are the devices, the bricks used in golf carts that are fairly common and very good at handling high power. They have low loss. They can be finicky or difficult to design and control the gate properly to avoid damage. That takes some attention. And there may be other kinds of switches as well. Looking at coil guns and stages, one thing I've not worked on but holds promise is that the first coil is the least efficient, and the second coil is more efficient because it's turned on for less time. As the projectile goes down the tube, each succeeding coil is on for a shorter and shorter amount of time, which leads to higher efficiency. So wouldn't it be interesting to find out what happens with a longer launcher and lots of stages? I hasten to point out that raising the power in a single stage quickly becomes highly inefficient because the material magnetically goes into saturation and doesn't accept as much energy, so increasing power quickly leads to diminishing returns. That's the science and physics of coil gun. There's also a number of tools that could be done to make coil guns easier to build, both for you and for others if you're so interested. Optical detectors are much less expensive these days. I show here a picture of an opto-interrupter in a small plastic tube. And for multiple stages, something like this is required. Wouldn't it be nice if more people could make recommendations and offer experience with certain parts and techniques to guide the next hobbyist here? A recent entry into the embedded controller game is the Arduino. If an Arduino is perfect for sensors and timing and dedicated control of circuits like this, I show a picture in the lower right of an Arduino with a generated fake display. Look closely, it's not connected to any other parts right now. This is just one possibility of how the display could work for an Arduino that is supposedly monitoring the actual speed of a projectile by using an opto sensor shown above. A common problem in coil gun hobbyist is just measuring the speed of these things. I have a couple of things on my website about how to do it. However, an optical sensor in Arduino is highly attractive and reasonably inexpensive. Wouldn't it be nice if the coil gun community had more programming examples and possibly a software library to work from for this? To pursue this further, I highly recommend a couple of links here, one of which is my own coil gun website. James Paul in the UK has another one with a fairly rigorous and scientific approach to it. I highly recommend the discussion community at the High Voltage Forums, 4hv.org, has a great number of scientific and engineering-minded hobbyists, and they're great at answering questions, or pursuing things further, or just sharing ideas and bouncing questions off of. For a first coil gun, if you're so interested, I recommend Chapter 1 from this book, 15 Dangerously Mad Projects for the Evil Genius. Written by Simon Monk. Chapter 1 is a free download that you can get and read. It's a sample chapter and has complete designs for a portable coil gun from beginning to end. And finally, here's a link to the finite element method magnetics, which is a great thing to plug. That takes us to the end of the prepared material. We'll open it up for questions and answers. Before I do that, I'd like to address a couple of questions that show up over and over again. One of course, is, so how fast are we really talking about for typical hobbyist coil guns? I recommend looking up a website. The World's Coil Gun Arsenal has a concise summary of coil guns around the world of various types and speeds. From this, I would say most coil guns have speeds in the range of 10 to 20 meters per second, and that's approximately 20 to 40 miles an hour, or if you think this way, 30 to 60 feet per second. A few coil guns are reported there up to 40 meters per second, but across the board, the efficiency of all of these is really quite low, 1 to 2% on a good coil gun. Very few are about 5%. Everyone wants to know where they can find capacitors. You want to find electrolytic capacitors are the least expensive for the amount of energy they can store. You'll want to look on surplus electronics outlets such as eBay. Craigslist often has some. An online store called Surplus Sales of Nebraska I've had good luck with. Some say that camera shops may have disposable cameras after the processor, which contains a small 300-volt electrolytic capacitor. You can chain a couple of those together. That might be one approach. Do be sure to compare capacitors based on the potential energy they can store. Potential energy is a combination of voltage and capacitance together. So you don't need to look at one rating or the other directly. Put them together. Potential energy is 1/2 times the capacitance in farads times the voltage squared. Many people want to know, well, if a certain voltage is good, isn't higher voltage even better? Well, don't get carried away. The strength of the magnetic field depends on current, not the voltage. So it doesn't directly matter what voltage you start with. The goal is to get the highest current possible. Specifically, you want amp turns, the simple product of current multiplied by the number of turns per inch. That's where the magnetic field strength comes from. And the most clever idea comes up fairly often is, well, what about launching a powerful neodymium magnet or some such instead of plain iron on the tube? That should increase the speed out the other end. I recommend you try it and see. I would love to have more people do the experiment and see what happens. All results are not in, but in practice, hobbyists often find no difference in the results, and unfortunately, it can erase the magnet.